Welcome to Privacy Now, your go-to podcast for privacy, crypto, and AI. Each episode, we dive into the latest advancements, explore cutting-edge innovations, and bring you insights from experts shaping the future of Web3 and AI. From crypto degenerates to the ones in it for the tech, Privacy Now has got you covered.
Hey everyone, welcome to Privacy Now, the podcast where we explore the bleeding edge of privacy, decentralization, and next-gen infra. As always, I'm your host, Mihnea, and today's guest is a very special guest, Filip Rezabek. He's the co-founder of SpaceComputer, a cutting-edge project, I would say. They're reshaping how we think about cross-chain security, and they're doing it in space. I'll have a bit of a longer intro than usual, but I find Filip's work fascinating, so I thought I would mention his progress. So Filip is a PhD candidate at the chair of network architectures and services at the Technical University of Munich, shorter known as TUM. They also have an amazing blockchain club. I'm in touch with them as well. A position held since 2020 after completing his master's thesis. His academic journey began with a foundation in communications engineering, culminating in a master's thesis titled Fault-Proof and Tamper-Resistant Certificate Issuance. Correct me if I'm wrong, Filip. Okay. This early focus on foundational security and resilience laid the groundwork for his subsequent doctoral research. And his current research at TUM spans a diverse but interconnected set of topics. And I want to mention everything because it will all make sense during the episode. So this includes network security, trusted execution environments, applied and threshold cryptography, system resilience, distributed ledger technologies, and time-sensitive networking. So the very titles of his research topics reveal a deep, long-standing preoccupation with system integrity and robustness from the ground up. For example, he has explicitly stated his interest in solving problems like how to recover a system when multiple subsystems are compromised, and how to assess whether a deployed system will retain its safety and security guarantees for a longer lifetime. Give me 1 second. I forgot to mute my notifications, sorry. This is not simply a focus on performance, but I would say on the long-term fundamental security and integrity of a system, a focus that is central to his entire body of work. And beyond his research, Filip also contributes to the academic community through his teaching responsibilities at TUM. He has served as a teaching assistant for P2P networks and security since 2020 and acts as an advisor for the IITM seminar. I say this dual role as a researcher and an educator positions him as a figure who not only pushes the boundaries of knowledge, but also effectively translates complex concepts for the next generation of engineers and computer scientists. This is evident from his collaboration with members of the TUM Blockchain Club, with whom he has crafted lectures. So I say we have a very interesting episode ahead. So I suggest we get started. And Filip, tell us a bit about your background. How did you go from academia to co-founding SpaceComputer? And maybe if you want to go a bit back with how you found your passion for everything you study at the moment.
Definitely. So thanks a lot for having me and the great introduction. It's like it's a lot of stuff you have been through, and I really appreciate that I can be here today with you. So with respect to my background, I think the journey started already many years ago when I joined and started to actively pursue my bachelor's. And at that point, actually, I traveled for a great experience to South Korea for an exchange student that really opened my mind with respect to opportunities out there. Always focusing on communication systems and beyond. And after I came back from my exchange back to Czech Republic, I said I want to explore a bit more. And that gave me a good inspiration to go for my not only study exchange abroad, but actually working abroad. And I landed a great opportunity at Cisco Systems in San Jose between my bachelor's and master's. So I spent 1 year in the mecca of technology, Silicon Valley. I was working in San Jose. And still working on systems, security, and more and more trying to find a passion for respect for research and having the flexibility of diving into deep technical topics, which later on when I afterwards basically joined my master's at UM, still focusing on communication systems and security. Naturally, I realized that there are two paths at the end. Like, do I want to pursue academic path with respect to having the flexibility and diving into complex topics, or go more into the industrial aspect? And from encountering different people along the way, PhD at that point seemed like a good opportunity to have the flexibility while working on cool technical topics. And the opportunity arose after the completion of my master thesis, as you were mentioning, which kind of led me to dive into the aspects of my PhD at the Technical University of Munich. And it so far fulfilled all of the expectations with respect to flexibility and having the opportunity to work on many cool topics in deeper sense, like you will have the time to spend and understand the fundamentals, but also work with many bright people along the way. And throughout the run of the work, I was always kind of open to ideas of starting my own business. Actually, during the COVID times, I was participating in many hackathons, where already I had the idea of like maybe continuing with doing my own stuff after I complete my PhD. Just the opportunity of SpaceComputer, at that point SpaceCoin, has arisen at the right point in time, where I got introduced to the team of SpaceCoin and SpaceComputer currently. Especially, I have known several of them, like Dalia Malki, especially her work is very known. And I was super excited to join and start to build a tech together. So trying to balance the aspects of strong academic background applied for a cutting edge research and implementations in the future.
But why specifically distributed systems and privacy tech? Like, well, what was the reason behind? Like, why were you drawn to this?
It's a great question. I think the aspect that really inspired me that we are surrounded by distributed systems in the context. Like, you have internet is like a huge distributed systems. When you are interacting with websites, you have front end running somewhere, you have back end running in different location, you have CDNs in between, and all of these are rather complex. And if you look at it, because my background is coming from the communications, you have so much data running around that in some way are leaking some sensitive information about you to the wild. And then also the part where the privacy comes into the picture, like how can we actually protect the individual information that we are leaking in our digital footprint. And with respect to that, of course, like security is fundamental aspect to protect the confidentiality, integrity, and other type of properties. But of course, if you want to extend it also beyond just the fundamental security aspects to get additional privacy, even for metadata, it basically is something that has to be combined in a interesting way. And I think that's the part that kind of drew my attention to complexity and finding a way on how can we preserve our present with respect to the information we are willing to share.
I agree. I mean, I understand because the more time I spend in crypto and surrounded by various projects, I do have a bit of background in network architecture myself because I owned a web hosting company, so we had a data center. So I'm quite fascinated by this as well. I saw that you guys describe Space Frontier as a cypherpunk crypto system for the space frontier. Could you walk us through the core philosophy behind this vision and how does maybe the physical isolation of space fundamentally change the threat for the threat model for confidential computing?
Definitely. So I will try to unpack it. So we are still kind of in the shaping on how to unify the narrative, but for everyone, it means slightly something else. For me, so starting with the aspects of Space Frontier, like we and myself including are great believers that the space is the next frontier with respect to the technology. We will start to see more space native application that will be running and made especially for the infrastructure running in space. We will start to see more interaction between different parties that just want to settle, operate, orchestrate through space native infrastructure. And we want to be part of it. So this is definitely something that with the respect of the increase of the investment, you name it, into the space industry, space is the next big thing that I think many people are passionate about. They are just like, geeking around being sci-fi nerds, and they want to see it coming, and we are happy to be part of it. And the aspect of the cypherpunk crypto system, at least for me, is the part that when we look at current systems on Earth, some of them are having fundamental challenges that are very hard to solve if you want to redesign everything from ground up. And we are very excited, actually. We have the opportunity to be at the time when actually the space industry and the aspects of distributed systems and infrastructure available to broader audience is in its infancy. It's just being built, and we are happy to contribute to it and try to maybe build it in such a way that some of the fundamental challenges that are in the on-Earth infrastructure can be mitigated. You mentioned one of them is the aspect of physical isolation. If you, for example, look at current trusted execution environments technologies, many of them do not consider sophisticated physical attacks. This is, of course, one of the part that combining physical isolation with the running in space basically helps to mitigate some of the current threats that are prominent on Earth systems.
Yeah, I know they're prone to side channel attacks, but they are pretty hard to do so. But again, you need to trust the network provider, you need to trust the data center, you need to trust a lot of parties for this. But we'll come back to this later. I would like to focus a bit on your work first, because I find your research fascinating. So first, I would like to focus on your work on consensus protocols. Because from what I've read, you've shown that Hastav, for example, break down pretty hard when you scale validator sets. And did this research directly influence the two-tier architecture of SpaceComputer?
Definitely. So with respect to that, like, it was a great teamwork that we have done with several of my colleagues at UM, and the focus of the paper was to understand how much can we actually scale the system with respect to throughput and how much transactions we can generate. And of course, taking this experience with us or with me is definitely something that I always have at the back of our mind with respect to applying algorithms like Hotstuff or others into the context of the space native layer 1 consensus mechanism. And we know that we are constrained on many fronts, both communication and computation, at least in the short to medium term. And we have to try to find a way on how to accommodate for the aspects of such systems. And for that, we are happy that we can, of course, use systems like Hotstuff, but also are investigating other state-of-the-art consensus and basically try to find a balance between good security, performance, and usability of the system as well. And taking this experience is basically something that we now try to project into the white paper that they are actively working on, and make sure that we can tick all of the individual boxes. And the aspect of the two-tier architecture was obvious to us rather from early phase, that we know that our chain will not be the next fastest chain, at least until we have laser pumps, and all of the future high-tech technology between all of the satellites. It will not be the one that can provide the highest number of validators, just due to the sheer that you cannot easily spin a new satellite and run your validator very easily. But we have to find a good compromise between security and performance. And for that, we are looking into the solutions on how to actually provide good usability to users on Earth. And L2s are the natural answer with that you can still have rather fast usability with the pre-confirmations coming from Earth. And we, of course, want to also extend the pre-confirmation with our additional security guarantees coming from the Space TE and others to provide these additional security guarantees to the users on Earth. So that way we don't necessarily have to compromise on security of the L2 infra, but can provide experience and usability as people are used to from other systems.
From what I've read, you guys bundle transactions, right? And finality happens on the space layer, and because of course transaction speed would be very, very slow otherwise.
Exactly. Yeah.
So
exactly.
You bundle transactions and yeah.
Yes, exactly. That's the idea, because the consensus, at least the way we currently model it, we will have to wait for a couple of minutes or seconds, depending on how are the physical constellations of the satellite at the point when you are proposing the blocks. But we are preparing for the rather high latency, and that's the part why we want to provide this aspect of reconfirmation to the users on Earth. So that way there is a confidence that maybe one satellite has seen it, it's valid state update, and they can continue with the process of generating new blocks on Earth as well. that will eventually get settled on one.
Yeah, makes sense. I was curious, like you've also published on MEV extraction and question arbitrages, and I thought you found thousands, if not more, like tens, hundreds of thousands of vulnerabilities. How does a tamper-proof space-based computer mitigate or even prevent these kinds of attacks that are, of course, common on Earth-based blockchains?
I think it's partially like also a philosophical question, right? Like in the context, like can MEV be preventable? I think as we see over time, like some aspects of the negative aspect of MEV are preventable, but the nature of MEV is very hard to get rid of the chain. Always there'll be some form of like people having information, trying to find, extract the value about the state. And I think that is the part that we are aware of. And the stuff that we want to focus on is how to prevent some of the negative aspects of MEV that can hinder the usability for people on Earth. And for that, of course, the current solution, if you look at the industry and where is the current state-of-the-art systems being built, for example, by Flashbots or others, we definitely see that TEs can play a crucial role. For that, the use case that currently is being applicable to the on-Earth MEV mitigation techniques using TEs is not something that directly that we can dive into because just we don't have the capacity and the latency that is required for such type of applications. But of course, due to the nature of providing confidential layer one, I think at least some of the negative parts is something that we want to mitigate on the layer one solution as well, and provide also the confidential guarantees from the L2s to the L1s as well. So we are investigating a suitable design on how to mitigate some of the negative externalities coming out of MEV.
Okay, so you also built something called multi-layer environment and toolchain for holistic network design and analysis, or better known as METHODA. And this is a framework designed to provide repeatable, reproducible, and replicable distributed system experiments with high precision and flexibility. The development of METHODA demonstrates a shift from a purely theoretical perspective to a hands-on verifiable engineering approach to research. Is SpaceComputer using a similar framework for its own R&D? And what kind of real-world challenges are you seeing that simulations just can't capture?
Definitely. So actually, it's one of the part that is like a great contribution that was done by me, but also several of my people and contributors on building the framework. And it's one of the methodology that is coming out of METHODA is actually something that we use at SpaceComputer as well. We are actively using the framework itself as a part of the collaboration we have with the TUM and the Chair of Network Architectures and Services, where I belong. And we are deploying and testing the respective system that we want to run in space using this methodological approach. So we are taking, for example, the individual building blocks that are contributing to the full-fledged layer one and layer two, and are using this framework to evaluate them and combine them and collect insights for us moving forward. Where the motivation behind it is, of course, if you want to understand how the system behaves, you can do it in different type of environments. Just this one is something that is made specifically for large-scale distributed systems to collect the insights and understand the different aspects of the blockchain stack and their interactions in between each other. And the other part that I think it's very relevant for us and where we see some of the challenges of coming and building stuff for space is due to the fact that you don't have the typical telemetry data that you are used to from on-Earth systems, right? You're gonna just like go and SSH into your virtual machine or AWS stuff to get the insights about what's going on. This time we will be happy if we at least know like it's reachable or not reachable, right? It's pretty much like binary. So we have to really have a robust framework on how to test and understand the system on Earth. Be able, for example, to emulate the latencies that we will observe in the real-world systems, meaning actually the space deployments themselves, emulate different type of failures, and so on and so forth. Emulate also different types of hardware specification and network constraints, basically the whole network model that you'll be operating in, to collect the holistic view of the overall system itself. So it's something that we are actively using, keep expanding it and making valid assumptions based from the simulation aspect, but also the emulation and the real-world deployments as well.
I love this, like frameworks for reproducible research. think this is fascinating. I would like to. So I was taking a look over the website and docs. I would like to zoom in a bit on the stack because you mentioned that your tech stack is a bit complex. So you're using TEs or space TEs, ZK-rollups, and I did see a mention of Apache, but we did talk about this. It's at the time being, it's pretty expensive to run. So, but everything adds a lot of complexity. Can you maybe walk us through how these components work together?
Definitely. So on the layer one, we are aiming to provide individual, we call it security services in our recently released roadmap, which basically will be the features that we want to provide to any type of user. So for example, Space TE is one of them there, where of course we ourselves will be using it for our confidential layer one as well, but we want to also allow others to come and deploy their applications on the TE itself as well. So this will be on the front of the space infra. We of course are using or planning to use ZK along the way on the space infrastructure as well for succinctness, for example, that if you want to have an attestation of your TE, you don't want to be sending all of the information, you just want to create a small proof out of it just for the sake of saving the bandwidth. And then the aspect of the on-earth solutions will be rollups, where we are investigating both optimistic and ZK rollups for the aspect mainly of scalability, but of course, we are also actively looking into the space with respect to actually what can we do also with privacy-preserving rollups like Aztec or other companies as well.
Okay. So you're using rollups basically for those transactions that are bundled
Correct.
for verifiability on. Okay. Yeah, that actually makes the most sense. So what are you guys building right now that you're most excited about?
I think we have multiple individual fronts that we are trying to push on. Like, so of course, we have a balance of making sure that we have some initial proof of concept that other people can get their hands on. So we'll be very soon releasing random beacon capabilities that will be actually fetching the randomness from space, the cosmic random number generator that people can actually take and integrate it into their oracles, their DApps, and other applications. We also are looking into use cases of integration of the randomness into cryptography protocols or consensus mechanisms themselves, like really on the fundamental layer. This is definitely something very exciting as the first, I would say, publicly facing product as of now, but we are pushing the envelope with respect to the Space TE 2.0 white paper as well. And that basically should be strengthening and providing the whole threat model of our TE that we want to be consuming ourselves, but also want to offer to external parties. And this is definitely something very exciting, at least from the part that I'm, it's very close to my research and my ongoing efforts. And on the other part, we are very active on building up the L1 itself. So it's basically like the blockchain stack with respect to the peer-to-peer layer, consensus client, execution client, and see how we can basically combine all of these components together. And we hope to have at the beginning of next year, have the first transaction or smart contract running maybe on a single satellite. Just basically want to really have the full flow of settling or executing our first smart contract on a space infrastructure in the future.
Nice.
So this is like very exciting.
That will be very exciting, yeah. So how does the stack work from a user, a dev, and a node operator perspective? Because I would assume it's expensive to become a node operator for SpaceComputer.
Definitely. So maybe let's start with the aspect of the infra, how we envision to do it. So as of now, we have access to one satellite, but we want to get access to more satellites. We also will be building some in collaboration with different infrastructure partners. And the idea is to use this initial experimental phase coming from us as a SpaceComputer to create a blueprint that basically others can later on chip in and basically run their validators like in the form of like a crowdsourcing that will eventually help us to build up the constellation for the mainnet. And with respect to the usability on the L2, it should be the same as people are used to from any type of EVM chain, just like basically try to deploy your EVM contract because we aim to be EVM compatible. and you can then just like easily port it, and you are good to go. So we already have a lot of challenges, and we definitely see the aspect of EVM being very commonly used in the industry, and are seeing a great synergies with respect to what we can provide to the users with respect to this stack as well.
I agree. So your target users would be like, who are the main users of the chain?
I think depending on the individual applications. So far, I would say we are mainly targeting protocol or enterprise solutions. So of course, the transactions will be a bit more expensive than what we are used to from on Earth. But the idea would be that if you have high security, high risk type of assets, you will be happy to actually have the additional settlement. Or at the same time, if you have, for example, solutions like the security services like CTRNG, SpaceTE, and so on, we want to provide these solutions to users on Earth to be able to leverage them and integrate them into their protocols. So in that sense, I would say we will be more in the initial phase B2B, but of course, eventually we want to allow any developer to come and deploy their smart contract or our platform as well.
Nice. And I know this is a hard question because you're still in the very early phases, but how do you envision SpaceComputer in the long run?
I think the main premise is to provide a permissionless confidential compute platform running on satellites in space. And for that, the premise is like that: provide the layer one, provide individual capabilities, where of course not for every application and use case you need the whole constellation of satellites. So there's also the part we want to, for example, provide for some applications like that are relying on threshold cryptography or MPC. Maybe you are just fine to run your execution across maybe 5 satellites, 6 satellites, just to get enough availability and security guarantees. And if you want, you can of course use the whole constellation as well. And overall, it should be serving users on Earth. But as mentioned, we are great believers in the space-based economy and space-based infrastructure. And that part, basically, we want to also envision a new set of use cases and application that we can help to orchestrate that will be natively running in space as well.
Okay. Since you mentioned this, how are you on space-based law? Because one of the things I loved in your talks is the mention of basically how space law is basically not. I'm using basically too much. Is non-existent when it comes to coding crypto. What kind of legal gray areas are you dealing with as you deploy systems in orbit? And do you think we'll need a regulatory framework for this in the future?
I think so. Starting from the back, definitely there will be a need for regulatory framework. At least as of now, it seems to be rather wild. I think it's like really, even though space has been around for a long time, I think certain aspects of it were overlooked. And as of now, it seems like that the parties that might be trying to enforce certain rules are mainly the infrastructure providers. So you can think of it, if I'm using Iridium or Starlink, they'll be the one that have certain terms and conditions. But as of now, it seems like that another aspect of law that actually will actually try to come and be enforced, it's very gray area.
Oh, okay. Yeah, so basically they're the ones who are responsible, as it was the case with data providers, with data centers, and in the past. Okay, so where else do you see confidential computing from orbit playing a role? Are you looking at use cases in AI, finance, defense? What are some of the use cases you're looking at the moment?
Definitely. So on that part, we definitely are aiming currently at the Web3 applications, because this is like really the thesis of the public permissionless ethos and the cypherpunks, right, that we are aiming for. But definitely from the discussion we have with different partners, and also people actually are either on our cap table or so, we also focus on Web2 use cases. So for that one, we are interested in, of course, AI. It's currently a hot topic. I think Google recently announced that they plan to run AI models on one of the infrastructure providers in space. So of course, the natural next step will be to provide confidential compute for AI models or other stuff in space as well. Especially if you start to consider that you have an infrastructure that can be operated by one party, and you will have other people using the infrastructure, naturally the aspect of security consideration will come to place, where you can think of it like applications of debris detection, where I have like a very specialized model and I want to run it on a confidential compute platform so that way other people cannot easily spot it. I will need some aspect of confidential compute. So this is definitely something interesting. And kind of on the aspect of financial services, custodial wallets, threshold crypto definitely go very much along the way. But of course, we are also interested in other type of hardware or maybe also mixture of hardware and software in other applications as well.
Yeah, but I'm like, how much more secure can you get than than knowing that it's literally secure this place? No, I just love your use case, and I was fascinated, and I'll definitely keep up to date with everything. I hope to get to meet you guys someday in person. We'll probably meet at the conference. Um, I just wanted to touch, and I hope you don't mind with this last question I have, because you've literally spent years navigating some of the most complex problems in computing, and now you're building systems in space. How does Filip unwind? Because I heard something about nature hikes and some selective taste in K-pop.
Definitely, I think K-pop and hiking, like, makes me push through sometimes. Like when you are like really, overloaded, it's good to definitely have a way to refresh, like either with good K-pop, like Blackpink and others. It's definitely fun, and or go for a hike, or run. So one of these is definitely something helpful. But with respect to managing, I think the complexity is just like really try to be systematic and handle one building block at a time and see how we can nicely fit together. And this was something that I've been working on for, as of now, quite a few years, and I'm happy that I can now apply it to real world problems that we try to solve.
Okay, nice. Well, Filip, the way I usually end these episodes is I do a lightning round. So I have a couple of questions. You can do short, long answers, however you wish. I think they're fun. Would you like to get started?
Definitely.
First question is favorite cryptography concept to explain at parties.
I really enjoy the aspects of zero knowledge proof. So now it's like it sounds like a magic, that I have something, but no one actually really knows what I have. This is like really the true magician type of a trick.
I'm in the TE field, so I usually explain the black box.
That's a good one as well.
Yeah. Most underrated tech in Web3 at the moment.
I think in general, I feel like, but at least from the recent activities, I'm happy it's coming back, but I feel like still privacy, I think it's not as dominant in the context of customer facing solutions. And I hope that actually it's going to be changed, like with respect to usability and providing privacy end to end.
I agree. I mean, people are and projects are starting to become more and more aware of how crucial privacy is, and I think we'll get there sooner rather than later. One thing you'd redesign about the internet.
I think the aspect of decentralization, like in the context that currently we see even though there is of course competition in the market, I think we start to be several big players, and I think having many smaller players could be something I would like to see.
Okay. This is kind of a double question, and I apologize I couldn't help myself since I'm a fan of TEs, but TEs in one word and some common misconceptions about TEs.
So T is in one word, fun, like it's been guiding me for the several years and I still enjoy it. And the aspect about misconception, I think first one, if I can, I have to say two. One part, like T's are broken. I think there are challenges with them, but I think they are definitely still very usable if you understand the threat model. And the other aspect is like all T's are the same, which I think is also not the case. There are implementation that provide different type of guarantees as well.
Okay. What's a Web3 concept that devs still get wrong?
I think some of the recent one, I feel like it's something regarding ZK-TLS. I have seen quite a few misconceptions regarding that. And the other one is ZK-rollups. I think many people still confuse it with aspects of privacy, but it's mainly focusing on scalability.
Okay, nice. Name a trend you're tracking in distributed systems or privacy that could reshape Web3.
Something that we are also actively looking into is the part on the distributed system front, which is do we always need consensus? And there are quite some recent interesting works that are actually looking into the parts that are trying to identify at which point consensus is a bit of an overhead and we can actually live without it. So this is something that is actually an interesting trend that we are actively looking into as well.
Okay. This is the fun one. If you could go out for drinks with one cryptographer, who would it be?
I think Adi Shamir, I have been reading his paper regarding Shamir secret sharing and others for many years. So I would love to, grab a beer and see and discuss.
Okay. This is a fun one as well. Favorite K-pop track? I'm sorry, I have to.
So I think that one is Omji Chok. It's the name of the song, and the reason for that is it means stump, and it's I would say a bit more of a 90s style K-pop song, but it has a very deep personal meaning for me.
Okay, I'm not into K-pop, but I'll try.
It's never too late.
I know it's never too late. A tech prediction for 2030. Bit late, I know, but
I think space DE is at Mars.
okay. No, I don't see why we wouldn't. Okay. Oh yeah, this is what the last question. Nice. We wasted them all. Is there anything I didn't ask you that you wanted to talk about?
I think we covered the aspect of the long-term vision. This was great. The stack, I think we went over. METHODA we covered.
No, but something that you want to mention, or I didn't think of asking you.
No, I think actually I really like the questions. Actually, I think they were very structured, kind of from the background, all the way on how they shape the part, and there is also SpaceComputer as of now. I think what can be a nice question if you think is with chilling, what is the next for SpaceComputer? We have a couple of stuff that I could try to chime in and make the community know what is the next steps for us.
Okay, I will leave I usually do this with all episodes. I will leave all of your details in the description of the episode. So I urge you guys to follow SpaceComputer on Twitter. Follow Filip. You guys are the next big thing in Web3. So I'm happy to have you here early on. But thank you, Filip. Thank you for joining. It's been a great episode. I hope our listeners enjoy it as much as I did hosting it. And I hope to see you again soon. Maybe we can do a follow-up episode in a couple of months once you guys have more updates.
Would love to really thank you very much for having me. It was a pleasure, and definitely looking forward to being in touch and contributing to the privacy and building up the cyberpunk space frontier.
Thank you, Filip, and thank you everyone for listening. As always, follow us, subscribe to Spotify, to YouTube. We have many more episodes coming down the road. Thank you. Bye.
Thank you. Bye.